Hi student, welcome back to the one more new topic, that is road estimating. So now today or from this video we are going to talk about the estimation of the earthwork related to that whatever the road work we are doing. Now in that road work we are calculating how much quantity of earthwork will be there, how much cutting will be there, how much filling will be there. So before going to solve those problems, we should know a few concepts about related to the earthwork, that is road estimation, that is particularly in the earthwork. So for that part I have taken some basic or we call it as a concept related to the earthwork. So we'll see the detail what is banking, what is cutting, then we'll go on solving those problems. Okay, we can see that in the diagram. So we can see here, so what is earthwork, how it looks like. The cross section of the earthwork, you can see the cross section of the earthwork of a road in banking or in cutting is usually in the form of a trapezium. See, you can see here, this is how the banking, this is ground level. Okay, banking is nothing but this is how we this type of figure we call it as a banking, and this is, you can see the cutting how it is ground level. So this is we going to call it as a cutting. Okay, so this entire figure we call it as a banking, and this we call it as a cutting. Okay, this usually in the form of a trapezium or a trapezoidal form. Okay, this is what we the point is saying, the cross section of the earthwork of road in banking or in cutting is usually in the form of a trapezoidal. You can see that in the figure exactly. It is how it looks like in a trapezium. It is the shape, exact shape of the cutting or a banking will be in the trapezium. Okay, and the quantity of the earthwork may be calculated by the following. So what is exactly the formula is to find out the quality and quantity of the earthwork is that quantity or a volume is equal to sectional area into length. So sectional area into length, then you are going to get the quantity of the earthwork or a volume of the earthwork, that is sectional area into length. Now what is sectional area? You can see here, sectional area is equal to whatever the areas is there. We are not going to get it directly, so we're going to split that area. So how will you split that area? First I'm going to make it a central portion. So central portion, this will act as a rectangle, so that is area of the central rectangular portion, that is this part. Then whatever the left out part, it may look like a, or it is look like a triangle, so we consider it as the area of two sides. It is in the two sides, other two sides of the rectangle, so we consider it as a two sides, or that is area of the two sides triangle portion, that is one side portion triangle and another side triangle portion, so we call it as a two side triangle portion. So sectional area become what? Area of the rectangle, then area of the two sides triangle. Area of the rectangle, this is area of the rectangle portion, plus area of the two sides, one side this, one side this, so two side triangle portion. So this gives you sectional area. If I go on doing area of the central rectangular portion, how the center of the rectangular portion is going to be find out it, that is breadth into depth. We will get B into T, that is the area of the rectangular portion. Now area of the two sides is that there is two sides, so I have written here 2 directly. Then what is the area of the triangle? If you go on finding out the area of triangle, that is half into this distance into this distance, right? Half into this distance into this distance, so 1 by 2 into HD, this distance into this distance, that is D. Okay, so totally if I solving this, 2 get cancelled, so we'll final answer of the sectional area is BD plus SD square. The sectional area is equal to BD plus SD square. You got a sectional area. Now in order to get the quantity or a volume is equal to what? The sectional area into length. So what is sectional area? You got BD plus SD square. Okay, if I substitute here in the sectional area and I will multiply with the length. This is what written. So therefore S is to 1 is the ratio of side slope as a horizontal and vertical. You can see in the diagram here we have written that S is to 1, S is to 1. Here also S is to 1, S is to 1. Now this is what is B? B is nothing but your right, and D is your depth. So SD is nothing but slope into depth, so we got this distance SD, so we are taken it as directly. Now what is S is to 1 is the ratio of side slope as horizontal is to vertical. For one vertical, horizontal is S. For one vertical, your horizontal is S. It may be whatever it may be the value, but S is nothing but the slope. We are taken it in the letter form or alphabet form. Yes, in the problem or in exact situation, they're going to give it in the form of number 10, 100, 20, 200, like that, go on giving the slope distance. Okay, so that for every one horizontal, the horizontal is S. Okay, similarly, for D vertical, the horizontal is S. D vertical, whatever the D vertical will be there, for that D vertical, your horizontal will be SD. D vertical, your horizontal will be SD. That is what written. So finally, the quantity is equal to BD plus SD square into 1. So how you got this? So quantity or a volume is equal to what? Sectional area into length. Right, now what is sectional area? You got the sectional area is area of the central triangular portion plus area of the two side triangle portion, right? So that is BD plus 2 into 1 by 2 into SD into D. So which finally got as sectional area is equal to BD plus SD square. So sectional area value will be substituted, that is BD plus SD square into length is nothing but L. So finally the quantity is equal to what? BD plus SD square into 1. This gives you the that is quantity of the earthwork can be calculated by using this formula. Okay, so next condition is next condition is you can see in this figure, or you can see in the screen, on the screen, when the ground is in longitudinal slope. You can see the figure. When the ground is in longitudinal slope, the height of the bank or depth of the cutting will be different at two ends of the section. And if the condition what is saying is that, see, you can see the diagram. So this condition height and this condition height is having different value. For example, d1 is equal to 6 meter or 6 to 2 value, 2 meter value, then d2 is equal to 3 meter. The two depth at the two different ends are different, right? Two different ends, the depth is different. So in that condition, how will you find out the mean height? So mean height is equal to what? D1 plus d2 divided by 2. So this d1 value, then this d2 value, both are going to be add and divided by 2, you'll get the mean height. See, what is this saying? When the ground is in a longitudinal slope, the height of the bank or depth of the cutting will be different at two ends of the section, and the mean height is nothing but this height is different, this height is different. In that condition, what we need to take, we have to take it as a mean height, that is d1 plus d2 by 2. Then you're going to get the mean height. Okay, now, so these are the things we need to find out. The total way of finding out this, the quantity of the quantity or volume is equal to sectional area into length. This is how we are going to find out the earthwork, that is quantity of the earthwork, by using this formula. Okay, the quantity of the earthwork may be calculated by various methods. See here, now we'll see the what are those methods. First we'll see the methods. Okay, the quantity of the earthwork may be calculated by the various methods of mensuration, out of which the three methods are given below. Is nothing but how we are going to find out the quantity of the earthwork. The quantity of the earthwork calculated by three methods. Okay, in that method, first we will see that first method number one. There are other three methods are there totally. The quantity of the earthwork, we need to follow these methods. Okay, method 1. What is the method 1? It says it is a mid-sectional area method. The method 1 is called as a mid-sectional area method. So in that, how will you calculate? The same, whatever the things we find out right now, that is quantity is equal to what? The sectional area into length, right? So same way, the sectional area is nothing but what? It's a area of midsection into length, area of the midsection into length. Now how area of the midsection? Area of the midsection is equal to area of the triangle, this triangle portion, then area of the two triangle portion, this is a two triangle portion, right? Similarly, what we did in the how you saw that in the first in the initial we saw now quantity is equal to BD plus SD square into length. The same we are finding, therefore the quantity of the earthwork is equal to BDM plus SDM square into 1. That is the same we are find out it. But the quantity of the earthwork may be calculated in the tabular form as below. Here what happens in this method is we have to find out the quantity of the earthwork by using some certain tabular column. We should follow some certain tabular column. Okay, so what happens, so that, so here in order to follow that, we have to take some simple or a tabular form. So what are the tabular form look like for the method of mid-sectional area method? So in that, the first column is station or a chainage, then depth or height, mean depth or height, area of central portion, that is we call it as a BD. Area of the central portion is nothing but a BD. Then area of the sides, that is HD square. We need to calculate these while going solving the problems. We need to go on drawing this table, and then we need to write down that what is the chainage or station, what is the depth of that particular station, then what is its mean depth, then what is the area of the central portion BD, then area of the sides, what is SD square. After getting all these values, then we need to find out the total sectional area BD plus SD square. BD plus SD square, that is in a separate table or a separate column. Then length between the station, what is the length between the station. When you write out the chainage, you will get that station length, that we will tabulate here. After getting that, the sectional area into length, we will get the quantity. Okay, if it is in banking, if you are getting the value in a positive, then you need to go for writing in banking tabular column. If your value is getting in a cutting, then you need to go on mention in the cutting column. Okay, this is what then after all this we'll get the we're going to make a total grand total of that. What is the total grand of embankment or a banking quantity, or at the final what is the total quantity of cutting, amount of earthwork we need to cut, amount of earthwork we need to bank in. So those values separately we're going to get that. At the final, all the values are substituting all these procedures following, then you're going to get the total quantity. This will be we will be doing it in the upcoming problem, so that I will going to you will get the clear picture of why we are using this particular table. Okay, this is the what the method number one. So method number one, it says that mid-sectional area method. So here also the same, the quantity is equal to area of the midsection into length. The area of the midsection is equal to the same, the area of the triangle portion plus the area of the two triangle portions. So if I go on substituting all these values, you will get the final value as a BDM plus SDM square into L. So here you can see DM is there. In the previously you saw the D. Here that is what, if you are right D is okay. If you are mentioning it as a DM, then we will take it as DM. If you are mentioning it as a D, then we will have to take it as a D. Okay, this is about your method number one. So now we will see what is method number two. So before going to the method number two, so there is one more thing we need to find out. What is that? That is nothing but area of the sides sloping surface. Now we need to find out the area of the side sloping surface. So what is that area of the side sloping surface? You can see here, whatever the thing is there, no, this part from here to here, this is the side sloping part, right? You have two sides, you have to get this side sloping part, or you can also see here this side sloping part is there. The area of the both side sloping is equal to 2 into length into mean sloping breadth. Yes, mean sloping breadth, right? Here area of the both side slopes is equal to 2 into length into mean sloping breadth. Now what is mean sloping breadth? Mean sloping breadth is equal to square root of SD square plus D square. So SD square plus D square is there. So here D square is common. So this is SD square. So SD square, right? So SD square is there in a bracket. So what happens SD square is there. So this SD square I will write it in a separately, so that you should not get any confusion. SD square plus D square in a square bracket. So what happens, SD square plus D square. So D square is common, so I take out from the square root, you will get a D square root of S square plus 1. So now if I substitute this mean breadth in this value, we will get area of the both side slope is equal to 2 into L into D into square root of S square plus 1. This part will be asked in the question to find out what is the area of the both side slope. So in that condition, you need to go on substituting this value, that is 2 into L into D into square root of S square plus 1 in order to get the area of the side sloping surface. Okay, so this will be asked in a problem as an additional question. So in that situation, we need to solve this. We need to go on substituting this values, area of the both side slopes, that is 2 into L into D square root of S square plus 1. Okay, so now what is the second method? So you understood the first method, right? The first method is nothing but mid-sectional area method. There also you saw that quantity area method of the section. We'll just brush up that method number one. And also we saw that the earthwork, quantity of the earthwork is equal to BDM plus SDM square into 1. The tabular column will be there. What is the content of the tabular column? So one column will be station and chainage, and another column is a depth or height, mean depth or height, or anything but a d. Area of the central portion BD, area of the sides SD square, total sectional area, that is BD plus SD square, then length between the station L, the quantity BD plus SD square into L. In that section we are going to take it as banking and cutting, or embankment or cutting. So those values will be written here, and whatever the calculated value will be there, that will be written, whether it is banking in banking you are getting, then we will write it in the banking column. If you are getting it in a cutting column, then you are going to write it as cutting value. Okay, so this is about the method number 1. So now we will see what is method number 2. So method number 2 is nothing but mean sectional area method. So we call that as a mean sectional area method. So it is also similar to that part. So what is happened here, the quantity is equal to, same, the formula will be same. So quantity is equal to what? Mean sectional area into length. So in the previously, what is again, it is a mid sectional area method. So area of the mid section into length, you will get the quantity. Here mean sectional area method, that is quantity is equal to mean sectional area into length. So now we need to find out what is sectional area, mean sectional area. So mean sectional area is equal to what? A is equal to A1 plus A2. A is equal to A1 plus A2. So now what is A1? A1 is nothing but sectional area at one end. So sectional area at one end means nothing but, you see the diagram. So we are getting this sectional area is 1, and this one is the another one. So that is what the sectional area at one end is equal to A1 is equal to B into D1 plus SD1 square. Sectional area at other end is A2 is equal to BD2 plus SD2 square. So where D1 and D2 are the heights or depth at two ends. Okay, so substituting those values, this value, that is A1 and A2 in the mean sectional area. What is mean sectional area? A is equal to A1 plus A2 divided by 2. If I substitute these values, so finally I am going to get as, you need to substitute that value. Okay, this, if I substitute this value by calculating the figure, and if I substitute those value, you will get A1 plus A2 divided by 2, and whatever the value you are going to get in the form, that will be substituted. Along with that, we multiply, if I multiply the length, then you will get the quantity. Quantity is equal to what? Q is equal to A1 plus A2 divided by 2 into A length. Then what is A1? A1 is equal to what? B, capital B into D1 plus S into D1 square. Now what is A2? A2 is equal to B into D2 plus SDD is D2 square. So if I get these values, then I'll substitute here A1 value, and I'll substitute here A2 value divided by 2 into length. You will get the total quantity. Okay, this is how we need to find out the total quantity. Okay, so the quantity of the earthwork may be calculated in the tabular form as given below. There will be a certain tabular form we need to follow, that is a station or chainage, height or depth, area of the central portion, that is BD, area of the side slope SD square, total sectional area BD plus SD square, mean sectional area, then length between the station L, then quantity BD plus SD square into L, that is if it is embankment, then you will write it in embankment form. If it is cutting, then you will going to write on the cutting side. Okay, this is the tabular column is same. This is method, we call it as a mean sectional area. Then one more method is that we call it as a prismoidal formula method. Okay, so prismoidal formula method, method number 3. The quantity or volume is equal to what? L by 6 into A1 plus A2 plus 4AM. That is your quantity of volume. So now what is A1 and A2? A1 and A2 is the cross sectional area, two ends of the portion of the embankment of the road. That is A1 and A2. As I told you, the A1 and the method number 2. So L is the length of the road, and AM is a mid sectional area. AM is a mid sectional area. Whatever the things we are doing now, for example, see, if I draw this like this, so now what happens here, right? This is how your embankment looks like, right? So here is some dotted line. So this will become A1, and this part will become A2. The mid section is somewhere here in the mid, somewhere in the mid part. Again we are going to calculate that area. Okay, so this will become mid section. This is one end and other end, and this is a mid section. Okay, so let what we'll do, let d1 and d2 be the height of the embankment at two ends and dm be the mean height at midsection. That is what I told you. This is a midsection, this is d1. So what is that? This is d1, this height will be d2, and this height will be dm. Okay, so now the cross section area at one end is a1 is equal to this end a1 is equal to b into d1 plus sd1 square, and the other end a2 is equal to b into d2 plus sd2 square, and the cross section area of the midsection is am is equal to b into dm plus sdm square. Okay, so where dm is equal to, as I told, if two different heights are there at the two other ends, means what we will take, we will take out this mean height, right? That mean height we consider it as a dm. So we don't have that particular value, but what happened, we know that this value and this value, so we will take out the mean value, that consider it as a dm. So dm is equal to what? D1 plus d2 divided by 2. So this is, we got that. Okay, now I'll substitute that am dm value in the am value. Okay, here I'm going to substitute the dm value. So am is equal to what? B into d1 plus d2 divided by 2 plus s into d1 plus d2 divided by 2 whole square. So if I do go on calculating, this is you're going to get as a am. Okay, now what happens, substitute a1 a2 am values in equation number 1. This is what the equation number 1, we will substitute those value, a1 value, a2 value, and am value. So if I go on substituting and calculating, the final value will be that this one, the quantity is equal to what? B into d1 plus d2 divided by 2 plus s into d1 square plus d2 square plus d1 into d2 divided by 3 all into length. So this becomes your quantity, that is prismoidal, that is a mean sectional area or a mean prismoidal area into length. So this is how we find out the quantity or a volume of the earthwork in the method by following the method of prismoidal formula method. So is it understood? There are three methods. One by one we will see that again, and we'll wind up this part. Okay, so in the road estimation, what we saw, that cross section area of the earthwork or cross section of the earthwork of the road is in banking or cutting will be in the trapezoidal shape. You can see here the banking and cutting part, right? The quantity or volume is equal to what? Sectional area into length. This is the ultimate formula, that is quantity of the or volume is equal to sectional area into length. So how will you get the sectional area? That is area of the central portion, that is this one central portion rectangle, plus area of the two sides triangle portion. This is the triangle portion, the two sides are there, so we have taken area of the two sides triangle portion. If I substitute that value of bd plus if I calculate the area of the triangle portion, that is b into d. So b into d will get the b into d plus 2 into that is 2 times of two sides are the triangle, so 2 we have written, that is the area of the triangle. This type of area of triangle is half into sd into d. This distance is sd and this distance is d. So if I calculate bd plus sd square. Okay, so now what is you can also see in the figure that is s is to 1 is given, that is ratio is the side slopes as horizontal is to vertical. For one vertical, the horizontal is s, that is what it is saying. Okay, similarly for d vertical, your horizontal will be sd. Okay, that is what written here. The final quantity is equal to bd plus sd square into l. Okay, in some case what happens, so at the both ends the height of the depth or height will be different. If in the both sides are in that situation, or in that case if the heights are different at the both ends, means what happened, we need to take a mean height, that is d1 plus d2 divided by 2. Okay, this is what we saw. Then after that we saw there is a three methods to follow to find out the quantity of the earthwork. That is method 1 is a mid-sectional area method. The same, the quantity is equal to area of the midsection into length. So if I go on calculating this, that is the central portion is nothing but your rectangle and two sets of the triangle values. If I substitute, you will get out with the bdm plus sdm square plus into 1. This is your quantity of the earthwork you need to find out. Okay, in order to get that quantity of the earthwork, we need to go on tabulating that part. So that in order to get the tabulation means we are going to draw it in a that is chainage of station in one column, depth in one column, mean depth in one column, area of central portion in one column, area of the sides in one column, that is bd and sd square. If I add both these two, we'll get total section area and multiply with the length, you'll get this part. If it is in filling, or if it is in banking format, then we'll write it in a banking column. If it is in cutting, then we'll write it in a cutting format. This is your method 1. Okay, similarly we also saw that the area of the side sloping surface, if the area of the side sloping is asked, then what is that thing, right? The area of the side sloping is equal to what? Area of the side sloping, that is area of the both sides, is equal to 2 into length into mean slope sloping breadth. Okay, mean sloping breadth is equal to what? Square root of SD square plus D square. That is equal to the squares are the D square. I'll take out the D square from the square root. We'll get a D into square root of S square plus 1. In this value will be substituted here. So that is the area of the both sides slope is equal to what? 2 into L into D into square root of S square plus 1. Okay, this gives you the area of the both sides slope. So then we came to know that method 2, that is mean sectional area method. The quantity is equal to mean sectional area into length. That is mean sectional area is nothing but A is equal to A1 plus A2 by 2. What is A1? A1 is nothing but sectional area at one end. A2 is equal to sectional area at other end. So that quantity is equal to A1 plus A2 divided by 2 into length. The quantity of the earthwork can be calculated. That the same tabular column we are going to use to find out that value. Okay, next we saw that the method number 3, that is the prismoidal method. So here also the quantity or volume is equal to L by 6 A1 plus A2 plus 4 into AM, where A1 A2 is the cross sectional area of two sides of the portion and AM is the mid sectional area and L is the length of the road. Let D1 and D2 be the height of the embankment at two sides and DM be the mean height of the mid section. Then we are going to get these values, and if I go on substituting these values in the equation number, that is A1 value, A2 value and A1 AM value, the final quantity will be B into D1 plus D2 divided by 2 plus S into D1 square plus D2 square plus D1 D2 divided by 3 into L. This is your total quantity. Okay, this is how we find out the we need to follow this in order to find out the earthwork quantity. Okay, these concepts are clear, I think. Now we in the next video we will see how to solve the problems on this method. Okay, thank you.